Okay, this video is entitled Everything You Always Wanted to Know About Truth Tables But Were Afraid to Ask. And we're going to deal with the mechanics of building truth tables. So if you think that you already have a good handle on how to make truth tables, then feel free to skip this video. And you can always come back and watch it if you need clarification. On the other hand, if you're struggling with truth tables, or if your truth tables end up having 5 or 7 rows, or if you don't quite know how to fill the cells with T's and F's, then this is for you. So how shall we proceed? We'll go through each of a series of 3 questions. They are, how many rows should my table contain? How should I assign truth tables to individual cells? How do I make a truth table for a sentence that has more than one connective? So, let's start with the first question. How many rows should my table contain? Remember that a truth table lists all the possible ways in which we could assign truth values to sentences. That is, it lists all possible cases, where each row corresponds to a possibility. If we are dealing with only one sentence letter, there are only 2 ways in which things may turn out. The sentence may be true or it may be false. So we only have 2 rows. For example, if X is, it's raining, then there are only 2 ways in which the world might be. Either it's raining or it's not. The first case we mark with a T, the second with an F. If we add another sentence letter, we see that the number of possibilities is exactly 4. It could be that both sentences are true. It could be that X is true and Y is false. It could be that Y is true and X is false. Or it could be that both are false. In fact, the number of rows in a truth table depends on the number of sentence letters we are considering. With 2 sentence letters, we have 4 rows. With 3 sentence letters, we have 8 rows. With 4 sentence letters, we have 16 rows, and so on. This means that whenever you add 1 sentence letter to the set, you double the number of rows in your truth table. So, with 1 sentence letter, you get 2 rows. With 2 sentence letters, you multiply the number of rows you had before, that is 2 times 2, for a total 4 rows. With 3 sentence letters, you multiply the number of rows you previously had, that is 4 times 2, for a total 8 rows. With 4 sentence letters, you multiply 8 times 2, and you end up with 16 rows. This relation can be expressed nicely and compactly in this way, where n is the number of sentence letters, the number of rows is 2 to the power of n. This means that we'll never have a table with an odd number of rows, or a table with 6 or 12 rows, for instance, since neither of those is a power of 2. Also, don't panic. In this class, we'll rarely, if ever, go beyond 3 sentence letters, so you don't have to worry about having to deal with gigantic truth tables. Are we all clear on this issue? Okay, next question. How should I assign truth values to my truth table? There are different ways to assign T's and F's to your truth table cells. But what we always require is that every possible case must be listed, and must be listed only once. To guarantee this, I recommend that you follow this procedure, which I call the halving method. Okay, we start with the leftmost column, and we assign T's to the top half of the rows and F's to the bottom half. So for instance, if you have 2 sentences, and therefore 4 rows, the top 2 rows will be assigned T's, and the bottom 2 will be assigned F's. If you have 3 sentences, and so 8 rows, the top 4 rows will be assigned T's, and the bottom 4 will be assigned F's. And so on. For the next column, the upper half of the rows, which was assigned all T's, gets divided in half. So one half gets T's, and the other gets F's. We do the same with the bottom half. This means that our rows get divided in 4 quarters. The first quarter gets T's, the second gets F's, the third gets T's, and the fourth F's. So, again, in the 2-sentence, 4-row case, this simply means that you alternate between T's and F's, starting with a T at the top. Here we're done with the table, and you can see that we've covered all possible cases. Now, if you have 3 sentence letters and 4 rows, what you have to do is reduce the number of successive T's and F's by half with respect to your previous column. So instead of having 4 T's in a row followed by 4 F's, you'll have 2 T's in a row, followed by 2 F's, followed by 2 T's in a row, and ending with 2 successive F's. And this completes our 4 parts. But we still have another column to go, and we follow the same halving principle. In the first column, we had 4 T's in a row. In the second column, then, we divided that by 2 and wrote 2 T's in a row. And in the third one, we divide again by 2 and end up with 1. So in this column, we basically alternate T's and F's. And then we are done. We have covered all 8 possible cases. The same procedure can be used with truth tables of any size. For instance, if we had 4 sentence letters, and thus 16 rows, the first column would contain 8 T's, followed by 8 F's. The second column would contain alternating groups of 4. The third one, alternating groups of 2's. And in the last one, we'll have alternating T's and F's. By the way, this doesn't change. No matter the size of the table, the rightmost column will alternate T's and F's. Okay, now to the next one. How do I make a truth table for a sentence that has more than one connective? Building a truth table for a sentence that only has one occurrence of a connective is very easy. You simply copy the truth table for the connective and substitute the variables for your sentence letters. For instance, a simple conjunction like A ampersand B gets assigned this pattern, which you already know, whereas a simple disjunction like C, V, D gets assigned this pattern that you're also familiar with. But what happens when a sentence contains 2 or more occurrences of connectives, as in this one? Here you should follow the order in which the sentence is constructed, and so you will start with the smaller components and work outwards from the inside, ending with the main connective. Let me explain this a bit. You build not E or G by first listing the sentence letters, 2 negating E, and 3 joining not E and G by means of a disjunction. Notice that in step 2 we start with a tilde, a connective that here only applies to part of the sentence. In this case, the sentence letter that forms the left disjunct. And we finish on step 3 with the connective that applies to the whole sentence, that is, the main connective, the disjunction. When we build a truth table for this sentence, we follow the same steps. First, we add a column for each of the sentence letters, which we already know how to do. Next, we do another column for the left disjunct, not E, which contains the negation. Here we simply follow the valuation rule of the tilde, which tells us to invert the truth tables with respect to the column that corresponds to the sentence that is being negated, which in this case is E. Finally, we make another column for our target sentence, not E or G. To assign truth values to the column, we use as a guide the truth table or valuation rule for the disjunction. Also, notice that we already have one column for each of the disjuncts, not E and G. So we use the values in these columns as inputs. The valuation rule for the disjunction tells us that we write a T whenever at least one of the disjuncts is true, and F otherwise. That is, if both are false. In the top row, G is true, so not E or G gets a T. In the second row, both not E and G are false, so the disjunction gets an F. In the remaining 2 rows, at least one of the disjuncts is true, and in consequence, the disjunction as a whole becomes true. So our truth table is done. It tells us that not E or G is false whenever E is true and G is false, and true in all other cases. Now let's up the ante with a more complex example. Look at this sentence. Here we have 3 sentence letters, so we have 8 rows and 3 initial columns, and we fill them according to our method. Then we start to build the sentence by assigning truth values to its components. The main connective here is a disjunction. We may start with either of its disjuncts. I'm going to start with the left one since it has only one connective, whereas the right one has 2. So we begin a column with A and C on top. Since the connective is the ampersand, we will be guided by the valuation rule of the conjunction. And we will use as input the values in the columns corresponding to A and to C. You will remember that the evaluation rule for conjunction says that a sentence is true when both conjuncts are true and false otherwise. In other words, it is enough that one of the conjuncts be false for the whole sentence to be false. If you scan the rows, you'll notice that A and C are both true only in the first and third rows from top to bottom. So we place a T in the corresponding cells, and F's everywhere else, because in every other row there is at least one F. Please take the time to check this for yourself. Okay, we're done with that column. Let's work on the right disjunct. You can see that it is the negation of a conjunction, and so its main connective is a negation. Thus, since we are working outwards from the inside, we'll deal with the negation last. So our next column is for C and B. Again, this is a conjunction. C and B are both true only in the first and fifth rows. So we put T's there and F's everywhere else. Next, we add the negation. And with that, we start the column for not C and B. If you remember, what the negation does is invert the value of the sentence it applies to. Here the tilde applies to C and B. So what we're going to do is that we're simply going to switch the values in the previous column. Wherever there was a T, we'll write an F, and vice versa. Okay, now we have our two disjuncts, A and C, which appears in our fourth column from left to right, and not C and B, which shows up in our sixth column. So we start a new column for a target sentence, A and C or not C and B. And we'll assign values to it using the disjunction valuation rule as a guide, and the fourth and sixth columns as inputs. You can do it line by line, comparing the row with the truth table. For instance, in the first row, we have a T and an F. And this is exactly the situation depicted in the second row of the truth table for the V. And in that row, the whole disjunction gets a T. The second row shows the same situation as the third row, and we get a T there as well, and so on for all the 8 rows. But you can take a shortcut if you remember that a disjunction is false only if both disjuncts are false. You will see that the only place where both disjuncts are false is in the 5th row from top to bottom. So you can simply write a T there and write F's everywhere else. In any case, you'll end up with this finished truth table for the sentence. Okay, this is all for today. Bye.